Good day, everyone. Today's video is going to pick up back in Arc Pro and focusing on how to make a buffer and a multi-reading buffer, and then how to essentially relate that to a select by location or a spatial join. And for today's example, we're using data from Little Rock's Land Bank Commission. You can see kind of a quick description of the commission itself, the mission statement of trying to reverse blight. They can obtain or handle or come in the ownership of properties a number of different ways. With that, it's available on their data portal, which right now is a black screen, but there we go. And it's through, you can see here, November of 2021, some of the properties that have spatial location in it, so we can use this. And it has some good information in it if you really wanted to get into like the purchase price and everything associated with the title. And to change it up and do something a little different, we're using data from Little Rock's 311 call services. With that, created a subset for 2021 related to animal services calls, and then looking at some subsets of those, mostly because I wanted to change it up and not always use crime data, and some students like to have projects related to other social issues. And 311 data is pretty interesting to look at, especially spatially, when you can see there's still disparities based on location. And I had a student work on an undergrad thesis that I was on the committee of, that focus on animal service calls in Little Rock, and some pretty interesting stuff that I hadn't viewed before in relation to some of our traditional criminological measures. But with that, downloaded all this data, and I already have it in Arc Pro. And you can see over here I have the land bank properties for 2021. I already changed the symbology of those to just look like a house, so all I did was truly type house, and we're good to go on that. I changed the color of the roads below to be a gray, so they're not standing out as much. I did, and this is a reminder, I already displayed the XY data for the animal calls. So if I were to open this attribute table and kind of show you the information in it, if you're not always allowed to download something as a shapefile, KML, or some type of spatial file, geospatial references in it, if it has latitude, longitude, XY, or some type of coordinates with it, it's still okay. You can right click on it. If you hit display XY data, Arc Pro is very good at reading through the sheet and trying to match X with longitude, Y with latitude. This one we know because I'm just familiar with Little Rock, the World Geographic Coordinate System for 1984, and it creates a new feature for you. All I did was change this name here, and that's what generated all of these points for 2021 animal services calls. So with that, a couple things that we wanted to cover today again is a buffer, and then how to join data to a buffer, and then a multi-reading buffer as well. So with that, we can see we have kind of a couple clusters of land bank properties just south of 630 here and south of 30 down here, and a couple scattered around, but none in our lovely West Little Rock area. With that, if you have never done a buffer, have no idea where to start, if you hop up to your tools option, you can see I already have it typed up here, but if you had no idea where it's located, all you have to do is type in generally what you're searching for, and it will still try to find it for you. So buffer, if you read it, is actually in our analysis toolbox. So if I were to come back and I drop down to analysis and then went into proximity, we have our buffer here. But again, if you were to just search it, it comes up for you as well. The cool part is you also have your multi-reading come up as well, so it is a nice one-stop shop for that. If I were to click on this, again, I'm wanting to put a buffer around our land bank properties. I'm wanting to know how many animal 311 calls for 2021 occurred within a specified distance around those. If you look at the extant literature on buffers and how they're used mostly in criminal justice, criminology related work, more so crime analysis side, you see this done with parks, bars, schools, especially when you have polygons. So you have parks that represent the entire park, and you want to look at crime within a 1, 2, 3 block buffer around that park itself. Schools in the same fashion. You can do it around points, polygons, lines. Today we're doing points. In the future we'll pull up some polygons for parks or even schools and look at what crime counts or 311 or other social issues occur within specified distances around some of those. So our input feature, what do we want to make a buffer around? That's going to be our land bank properties. Our output feature is going to my geodatabase, so my project folder for this. I'm okay with that. All I'm going to do at the start though is put no dissolve, and I'm going to show you just the difference between a dissolved and non-dissolved buffer. For this one, let's go ahead and do 0.5. So we're going to do 0.5, so it's going to be half mile. We're just going to change it up on a couple of different ones. And if you have not done a buffer before, there are 3 different options within Arc Pro. If you ever have curiosity or questions about it, if we were to hover over that eye to the left of dissolve type, it actually gives you a description of what each one is. And I'm going to make a dissolved and non-dissolved, and then we're going to go over some of the differences with those. It's very easy to see visually, so that's why I'm going to do it that way first. So I'm going to start off by making 2 buffers that are exact same. One's dissolved, one's not. I'm going to hit run. So that's going to generate here for us, and I'm just going to move it above our streets. And then I'm going to do the same thing. I'm just going to take the no out of dissolved. Everything else is the same, still land bank properties, but with that we're going to change it to dissolve all output features into a single feature. Hit run. I'm going to change the symbology, essentially the color of this one, just so we can see a bit of a difference between them. So the first one, I'm going to zoom in on a little area here. So you can see now each specific land bank property has a buffer around it. That can be good and bad depending on what you're wanting to do. If you're wanting to get a true count for each individual land bank property, this is a good way to do it, because when we do a spatial join, it will give you that count. The issue is if you're wanting to look at the aggregate of all land bank properties and how many animal related calls are around it, you're going to have multiple counts based on the overlapping buffers. So here you can see that if you were to essentially have a Venn diagram, that the overlap could potentially have multiple counts. You can see if I turn on that animal layer, there are some that fall even within this area here. So it would be counted technically 3 times for one call. That can be problematic. Again, it depends on the type of question you're asking. The difference is when you dissolve it, you can see now that there aren't overlapping. It truly is just one buffer itself, and it gets rid of that. It's an easy way to see that is kind of turn it on and off. But you can see the boundaries of that. You no longer have a buffer per property. It's just when there are overlapping ones, it dissolves that into one, and we're good to go. So now that we have both ones, we'll show this a couple different ways to kind of walk you through this process. In the past, we've done select by location. So if I were to turn on this animal layer, so our points of animal 311 calls, and I did a select by location. Since we have our buffers, we could change this. I'm going to just do our dissolved one here. We can say our land bank dissolved buffers contain, and we want to contain our 311 calls. And with that, if we hit apply, oops, I did it backwards, and I've done this in class. So if you notice, it actually selected the buffer itself versus what I wanted to select. So my input feature should be our animal 311 that's within our dissolved buffer. Change it there, and again read it as animal 311 within, and what are we selecting based on our dissolved buffer. Hit apply, and you can see now we have a bunch of selected animal calls. Again, if you want to look up how many there are, if you were to open the attribute table and see at the bottom here, there's 561 out of just over 2,500, so a bit over 20%. And part of the homework assignment related to this is making an infographic for Chattanooga based on some spatial joins in a specific high school. You can take this number here, so we have 561, and if you want to turn this into a percent, divide by the total of 2543, and then to get a true percentage, times it by 100. Oops. And of course I hit too many things, so 561 divided 2543 times 100. We have 22% of our animal calls are within a half mile of our land bank property. So you can take that 22% and use it as a graphic on an infographic, just describing if the purpose is land bank properties and what's happening around them or in some fashion with it. You can take this, and it's an easy to use percentage versus trying to say 561 about 2,543. Easy way to summarize what you did here. Now with that, this is what we've done in the past. The new way that we got into last week and the past couple weeks is doing a spatial join. So if we wanted to join data, we want to join a count. So we want a count of how many animal 311 calls there are in the buffer, our dissolved buffer specifically. We want to join data to that. So if I were to right click on our dissolved one here, our layer here, and I'm going to go to a joins and relates, a spatial join, and I want to join our animal 311. I'm just going to put joined at the end of it, 1-to-1, and we're going to say our land bank properties contain. And for our purposes, and I hit on this in a couple different videos, I don't need this output field information here. It's coming along with the animal 311 calls. So all this does is clean up my attribute table ahead of time. You can still do this on the back end and just delete a bunch of them. For our purposes today, no need for them. If you're following along as a student in the class, you don't have to worry about this because we'll still have our join count. So if I run that, it's going to pop up, and if I were to open this attribute table for this new layer, we see that our buffers around our land bank properties contain 561 animal service calls. That's what we expected. That's what we almost a duplication or trying to make sure we had the right number. We're good to go there. But now I want to show you if you wanted to join the same data to our non-dissolved buffer. So say you truly wanted to know how many animal calls there are per actual land bank property, you would do a similar spatial join. So I would do a right click on our non-dissolved buffered layer, go to our join relate, spatial join. Our join features is still going to be the animal 311, and I'm just going to put joined at the end of this one. Still contains, and it's still a 1-to-1, and I'm not going to get into the fields like I did on the other one. I'm just going to hit OK. And now if I open this attribute table, you can see that each individual, I'm going to turn off one of these layers so we can see it a bit easier. Each individual buffer around each of the 36 land bank properties has a count now. So this first one here, you can see that's highlighted here in that bright blue, had 67. If we come down to the sixth one over here and moves a little to the west, it had 147. Total well beyond the 561. So that's where you do have duplicate counts based on that. So that's depending on your research question you're asking. It can be valuable to do a dissolved or non-dissolved buffer. It depends on that specific question. That's why I always say take some time on the research side in terms of questions, hypotheses, to figure out what type of analytical approach you want to use. Interesting, since I'm zoomed in on it, this is where I did my PhD back in the day at UALR, which, if you're familiar with Little Rock, is actually in a somewhat a very high crime area. But that's for another video, another day, all that good stuff. But all right. So we've done an easy buffer in terms of just one unit. ArcPro does give us the ability to do a multi-unit, multi-ream buffer. So with that, I'm going to turn off our current buffers. And say I was interested in, how many land bank, doing a block to 2 block buffer around our land bank properties to see how many animal calls there are in that fashion. So it's an easy way to see as the distance increases what that looks like, but keep in mind as we create more reams around it, the area also increases. So that's why a lot of people use a location quotient to get around that, or to take area into account some fashion. Again, beyond this video, but just keep that in mind if you're watching it for other purposes. So with that, go through the same process. Again, I had the Tools tab open, so if I hop back down here to Geoprocessing, you can see that I still have the buffer open. If I click on the back arrow, I still have it from my search screen. If I come down to multiple ream, same process. I'm doing a buffer around my land bank properties. Output feature, I'm fine with it being just called a multiple ream buffer. Distances, let's just do the streets aren't, let's see, it's around 430, so let's just do 400 feet as block for now, and then we want to add another to make it a second block around it. We can even add a third if we really want to get into it at 1200. Our unit, this one is feet related, and this is just going to be 4, 8, and 1200 feet. So still well less than the half mile. If you remember, there's 5,280 feet in a mile, so well below that. No overlapping reins. So that's another dissolve option here. So it's dissolving that for us. And with it, go ahead and hit run. And I like that it's zoomed in now because it will show these reins for you once it's generated. And there we go. And I'll go in here real quick into the Symbology to change the color of the reins, just to make it easier to see the differences across those. So if I were to come up to my appearance, Symbology, graduated colors, and all I'm going to do is change it. Oh, it picks it up for me. So it changed it based on the distance itself. So if I were to open this attribute table, you can see the 4, 8, and 12. So we're good to go there. The length, same thing. So if I even were to change this to the distance, it's not going to change the colors in here, but we're okay if you want to see it that way. So you can see we still have dissolved buffers, but as they go up from a block to 2 block to 3 block, what that looks like. And that's where I say the area difference changes based on that as well. Similarly, we can still do a join on it. So a spatial join here, if you have, I'm going to turn on our animal layer here, each one's going to have an individual count. So we'll know how many are in the first screen, so within 400 feet, and then essentially 401 to 800, and then 801 to 1200. So they're going to be distinct and unique counts based on the buffer rein that they are in. So if I were to right click on our multiple rein buffer, go into joins and relates, and add a spatial join, I still want to join that animal layer itself. Save into my geo database, so I'm fine with that. I'm just changing this to a contains. So my land bank property multi-rein buffer contains our animal 311 calls. Hit OK. And as that generates a new layer for us, I'm going to open that attribute table. And at the start here, you can see that within that 400-foot band, we have a total of 69 animal 311 related calls. If we go to the 2 block one, we have 120. So again, that's essentially 401 to 800 feet. And then our third rein goes from about 801 to 1200. And you see we have 89 there. So these are distinct counts based on that itself. It's pretty interesting that I honestly expected the third one to be a bit higher, but given the type and where these properties are, still makes sense. So within 2 blocks, you kind of see that upward trend, and then it declines back down. And you can see over here, and this is, we haven't got into clipping or anything like that at this point, but some of these areas don't have streets on them to where you could not have crime or 311 calls geo-referenced to. Another example of this is down here in the corner, where it actually goes beyond the boundary of the city. Again, another video, another time, but it's things to pay attention to and think about when you're looking at your data, potential issues with it, of where can our point data actually be located, where are buffers located, are there any issues to think through related to that. When you're in the heart of a city, you can see that there's a lot of cross streets in here, so a little different that way, but still some park area that you could not have some crime go to. But with that, this is a quick video. When I say that, it's still about 20 minutes relating to making a regular buffer and then a multi-rein buffer and joining data to that. So if you wanted to show a multi-rein buffer, obviously you can display that, and you can even put text boxes to say on an infographic. If you zoomed in to say one school, and I'm saying that because that's part of the assignment, you can put the count in each rein of how many crimes there were. You can change the symbology based on that as well. So you have a lot of opportunities to take our spatial analysis in here. And for the assignment, we did a quick brief introduction to Canva, more so to get the students to spend some time in Canva, so when it comes to their project, they're a bit more familiar with it, and it's due in about a month from now anyways, so they have some practice in it. Again, you can use PowerPoint, but Canva gives you a lot of cool visualizations and graphic design options that are a little different than PowerPoint itself. So with that, if there's any questions, feel free to reach out. When summer comes around, I'll be making a lot more videos related to GIS, QGIS, and Excel related to our open source textbooks that we have going on. So again, feel free to reach out. Until next time, cheers.